Hello students and welcome to IP Study lecture videos. In this video, we are going to cover chapter 8 of grade 6 and the name of the chapter is Playing with Constructions. So first of all, let us see what are the different topics we are going to cover under this chapter. So we'll see what are curves, then we'll go to find out how can we make circle and semicircle, and then we'll study about the properties of square and rectangles, and then at the last we'll see how we can construct square and rectangle with the given information like two sides or a value of diagonal cutting, the corner angles, etc. So without wasting the time, let's start with our first topic, and the topic is curve. What is a curve? A curve is any shape that can be drawn on a paper with a pencil without lifting it. So on a paper, if you draw a shape without lifting a pen, then the shape is called a curve. It can be of any shape like this or this or this or a line only. Okay. Now, there are two types of curves that we need to know. One is open curve and other is closed curve. Open curves are curves that do not and at their starting point. Let's suppose if we started a curve over here and just it goes like this and we don't come again to the starting point to end it, then this is open curve which looks like this. After that we have closed curves which has same starting and ending point. If a curve started over here, then after moving again and again it will come to the starting point only. So the starting point and ending point of a closed curve is same. Okay. Now next is from drawing to constructions. We can draw various figures or shapes using pencils, but without using the instrument like ruler, compass, protractors that we get in our geometry boxes will be little difficult. So now we need to know how to construct different figures using these instruments. Yes. Now the special curve, from the curve there is a special curve circle that we need to discuss in detail. A circle is a special type of closed two-dimensional curve or figure having no straight edges or corners. You can see a circle over here. So it has no straight edges or corners. Yes. While we use a ruler to construct a perfect straight line, as we know that to construct a straight line we need a ruler, but to draw a circle we need a different instrument. Straight line will not work there. Yes. In the next section we will explore how to construct a circle. Yes. So the next topic is construction of a circle. Now we know a circle is a special kind of a curve. So we need to understand how a circle is formed. So here we have an activity that shows how a circle can be formed. In your notebook, mark a single point and call it as P. So you have to mark a point like this, a P. Now using the ruler, find and mark at least 10 or 15 or 16 points which will be at the same distance from this point P. Like this 1, this 2, this is 3, this is 4. And now if you join all these points, a circle will be formed. So circle is a collection of points which is at a same distance from single point, and the distance between that single point to any point on the circle is called the radius of the circle. Okay. So from the above activity we can conclude that circle is a closed curve where every single point is at a same distance from the fixed point. The fixed point is called the center, and the fixed distance from the center point and the point on the circle is called the radius. So next is diameter. So diameter is twice the length of radius. So diameter is actually a line that passes through center and is made up of two radius. So it should pass through the center and it should be a line segment which joins two different points on the circle. Yes. So the next topic is compass, the tool for perfect circles. So in your geometry box, you will find a tool which looks like this and is often called as compass, which will have a compass needle, a pencil holder and hinge at the top. You can just rotate the compass to form a circle. Let us see how we can do that. So steps of constructing a circle. So constructing a perfect circle with a pair of compasses is a simple and precise process. So in order to draw a circle, we need to identify the radius that we need for the circle. So let's suppose if we have a radius of 5 centimeter for which circle is to be drawn, we will open the compass and we'll put the needle at the starting point, that is 0, and we'll set the radius like this. The pencil will point out the value of the radius, that is 5 centimeter as of now, and then we'll fix a point to place the needle of the compass and we'll rotate the compass, which will form a circle like this, and you will see a complete and a real circle after drawing that figure. Yes, so this point is the center at which the needle was placed, and this is a circle that is formed after rotating the pencil. Is it clear? Moving to the next part, semicircle and its construction. So semicircles can also be created with the help of compass. Let us see how. So in order to draw a semicircle, we need to find out its diameter. But first of all, let us understand what is a semicircle. So in a circle, if we divide a circle into two equal parts, the first part or the second part are equal and are called semicircle, the half of a circle. So along with the diameter, it is called a semicircle. Yes. Now, in order to find out the perimeter of semicircle, so it can be in two ways. If they have asked about this length only, so it will be okay. But if we have been asked about the length or the perimeter of this figure, then this will be added to it. Yes. Now, how we can draw a semicircle? So in order to draw a semicircle, we need to identify the diameter of the semicircle, that is the twice of radius of the semicircle that we need to know. Okay, so after that we will just place the compass needle over here like this, and we'll place the pencil over here and we'll rotate the pencil keeping the compass needle steady, and we'll reach the point B, and there will be a formation of semicircle like this. So these are the steps which we can follow to draw a semicircle. Now here is an example which shows how we can construct this figure. So here a semicircle is drawn using a line segment AB, and after finding out the midpoint of this diameter of the semicircle, we can again draw a semicircle using the midpoint of this line segment OB, and this will form like this. So we have to think creatively to draw a given figure using a compass. Yes. Moving to the next topic, squares and rectangles. So we already know that what is the meaning of a square and what is the meaning of a rectangle. So a square is a quadrilateral which has all four sides equal, as well as the angles are all equal and also 90 degree. Rectangles are quadrilateral which have opposite equal sides and each angle is also 90 degree. So every square is a rectangle, but every rectangle is not a square. Now a rectangle is as we know that a rectangle is a quadrilateral in which opposite sides are equal in length and all four interior angles are at right angle. Yes. So in a quadrilateral we have vertices, sides, opposite sides, etc. that we already know that vertices are the corner points, the sides are the line segment that has been used to draw the quadrilateral. Yes, and opposite sides like this, these two are opposite sides and these two are opposite sides. Now to name a polygon we can use any direction, either clockwise or anti-clockwise, but all the points should be in order. Like if you start with B, we can go like B, A, D, C, or we can go like B, C, D, A. So order is the only thing that we need to remember, and we can either move in the clockwise or anti-clockwise. Like we can't name this figure as B, A, C, D because the order has been broken. After B, A we need to write D, not C. Okay. Now rotating a square and rectangle. Whenever we rotate a figure like square or rectangle, its property doesn't change. Like this square has been rotated at 45 degree. Now also the sides are equal, the angles are at right angle, all the angles are right angles. So the property of a quadrilateral, or we can say the property of a square or rectangle, doesn't change when we rotate the given figure around any degree. Yes. Now observing a square and rectangle on a grid, we can find out on a grid paper that if the given square or rectangle is a square or rectangle or not. Yes, like here, if we see, we have a figure where we have been using 4 dots horizontal and 3 dots vertical. So whenever two line segments are aligned vertically and horizontally, they form right angle. And here we can see the opposite sides are equal. We can say this is a rectangle. Here all the sides are equal. We can see that there are equal number of dots used to form this figure, and also the sides are aligned vertically and horizontally. That's why the angles are also 90 degree. So we can say that this figure is a square. So in order to become a square or a rectangle, the line segments or the sides of the figure of a quadrilateral should align with vertical and horizontal grid dots. Yes, but sometimes what happen is we don't have the sides aligned with the dots. They may lie in the rotated form like this, aligned with the dots, or it may be not aligned with the dots but rotated like this. So in this type of cases, we need to check if the alignment of the sides are symmetrical about the dots or not. Like here we can see that this side is symmetrical about these 2 points. Also in the same scenario, these are symmetrical to this point. So when there is a symmetry between the dots and the sides, we can say that the right angle has been formed, and we can see that the length of the line segment in all the 4 cases are equal. So it may be a square, which we can verify using the geometric tools like protractor and all. Yes, by measuring the length of the side using ruler and the angles by protractors. Yes. Next, moving to the next figure, here we can see that this angle is greater than 90 degrees. So it can't be either a rectangle or a square. So that's how we can identify if a given figure on a dot grid paper is a square or rectangle or neither of them. Clear? Moving to the next part, constructing squares and rectangle with given sides. So we need to draw squares or construct squares and rectangle with the given information. So in this chapter we will be dealing with 2 different type of scenarios. One with rectangle and square with given dimensions of length and width. For square it will be one value only of the side. For rectangle it will be the value of length and the width. And second type of scenario that we will get is having a diagonal dividing the square and rectangle in some values that we'll see in the later part of the chapter. So with the first topic of drawing or constructing a square or rectangle using given dimension of length and breadth, or in case of square the side length. So in order to construct that, what we can do, we can start with any base length. Let's suppose AB as 7 cm, we need to draw rectangle ABCD. So AB is 7 cm, which we can draw using the ruler. Now we know that every side which will be there will have 90 degree angle with the base. So we'll draw a 90 degree angle using the protractor by placing and aligning the center point with the left side dot or left side part, and we will then construct an arc of 4 cm over the right angle that we have drawn. Similarly on this side also the same process will be followed, and after that either we can draw a right angle from D to this point or from this point C to D, and it will meet. If we draw from D it will meet at C, and if we draw from C it will meet at D. So various steps can be followed after initial drawing of base length and right angle. So it's all up to you what step do you want to follow. So here the steps are given which you can go through and understand the one of the method of drawing this figure. So square is constructed in a similar manner where the length of the sides are same. So just drawing the side and then constructing the right angle, and then after that constructing the other right angle like this. Yes, and then finding out the value using the compass, that is drawing an arc of 5 centimeter as all the sides are equal. So measuring the compass using the ruler as 5 centimeter and just drawing an arc to just give the value of side length as 5 centimeter, correct? So after these all point, you will able to find out the required rectangle or square. Next topic is exploring diagonals of a rectangle in squares. We know that every quadrilateral has two diagonals. So this will be the same case in rectangle and a square. So in a rectangle, PQR is given over here. The line segment PR and QS are the diagonals. Yes. And for this square also, PR and QS are the diagonals. Now here we have an activity where we can find out that how diagonals intersect or bisect each other, as well as the length of the diagonal in both a square and rectangle are equal. In square, the diagonal divides the angle in two equal parts, like 45 degree and 45 degree. But in case of rectangle, it can divide in any value, like 90 degree angle can be divided into 30 and 60, etc. Or 45 and 45, then it will be a square basically, or 35 and 55, etc. So in rectangle, it can divide in any value. And square, it is always 45 degree, 45 degree. So if we draw a square and if we draw a diagonal of the square, it will divide the angle of the square in equal parts, that is 45 degree and 45 degree. So properties of rectangle. In any rectangle, the two diagonals are always equal in length. There are many properties related to diagonals, but for this chapter we need to know only one property, that in a rectangle the diagonal are of equal length. Yes, it means the length, if this is a rectangle, then length of this diagonal and this diagonal will be equal. Next is properties of diagonals of a square. So we have three properties. One is, like all rectangles, the diagonal of a square are equal in length, as all the square is a rectangle. So property 1 will be valid for square also. The diagonal bisect the corner angles, cutting each 90 degree angle into two perfect 45 degree angles, as I have told you. The diagonals are perpendicular to each other, meaning they intersect at perfect 90 degree angle. So there is one more property in which a rectangle, when given with the diagonal, it bisect the diagonals, as well as the angles at the bisection point is 90 degree. Yes. Now, so starting with the next topic, constructing rectangles using diagonal properties. So in this section, we'll understand how to construct a rectangle in two cases. One, when we will be given with the side length and the length of one diagonal. And the second case will be when we will given with the value of the angles created by diagonals at a corner. So let's start with the first, constructing a rectangle given one side and a diagonal. We already know how to construct a rectangle when we have the length of sides of length and width. Yes. So using the same and similar concept with slight changes, we'll construct the rectangle with the help of side length, not the width. Instead of that, we will have a diagonal length. So we need to draw the base as the sides that we are given with. Here we have a question. Construct a rectangle where one side is 5 cm and the length of the diagonal is 7 cm. So we'll draw the length of the side 5 cm, and we know that here we'll be having a 90 degree angle like this. So we'll draw using the protractor 90 degree at both corners, which we can do one by one or once at a time. Now let's suppose if we draw one of the right angle like this, and if we want to know the next vertex B, we can draw using a compass placed at D and making an arc on this line, which will give us B. So this length will be same as the diagonal length, that is 7 cm in this case. After that, we need to find out the fourth point T, which we can find in various ways. Like we can have another right angle and we can draw an arc again because the diagonal length is same. So we can have our D over here. Yes, these already there, so we'll have A. So we can find out in this way also. Or what we can do is we can take arcs measuring one from D, which will be equals to BC length, and one from B, which will be measuring CD length. So there are various ways once we have drawn or find it out the vertex B. After that we can use any one of the method to find out the vertex A. After completing the rectangle, we'll get ABCD like this. Clear? Now, next is constructing a rectangle using corner angle divided by a diagonal. So, in some question, we will be given with a diagonal which will be dividing, not the length of the diagonal, but the angles divided by the diagonal at a corner. Okay, so let's suppose if you have a question, construct a rectangle where diagonal divide one of the right angle, that is 90-degree corner angle, into angles of 30 degree and 60 degree like this. Let's suppose this is a rectangle and this is a diagonal. So one will be 30 and other will be 60 degree. So we don't have any side length. So it's all depend on you that how much side you want to have, because for the given information we have different number of rectangles, but all will be having same thing, that the diagonal divides the corner angle into 30 degree or 60 degree. So we can take 5 centimeter length or 7 centimeter length. So all the rectangle will be the scaled version of one that you will be drawing. Yes, so let's suppose we taken a length AB of how much we want, all depends on us. Okay, after that we'll draw right angles. Or directly we can jump on drawing the first angle 30 degree using the protractor aligning with the center point, and we'll have 30 degree which will cut this right angle which we have drawn over here like this, and this point will give us point C. Now for D we can again repeat the same process, or what we can do is we can measure the length of BC and we can make an arc from A which will give us D point. Yes, or we can also measure AB and we can make a right angle at C and we can just make an arc which will be equals to AB, which will give us D. So we can see there, after starting the initial steps, we can have 2 or more ways to construct the last vertex. Yes, so after completing the rectangle, it will look like this, A, B, C, D. Okay, moving to the next topic, points equidistant from two given points. Let's suppose, what does it mean? Let's suppose if we have 2 points and we want to draw or find out a point which is at the same distance from these 2 points, how we can do that? So if we draw a circle from A of, let's say, any measurement using the compass, so this will give us circle like this, and from B it will give us circle like this. Yes, so there will be a point from which these 2 points will be at the same distance. So for that we need to draw arcs from A like this and from B like this of the same measurement, and the intersecting point of these 2 arcs will be the point which will be at the same distance from A and B. Yes, so here we have steps to draw a point which is at the same distance from A and B. Okay, so this is how we can draw various shapes, like we can draw a rectangle with given side lengths. Yes, using this concept, like let's suppose if we consider the example 9, construct an isosceles triangle ABC given the base AB of 4 cm and 2 equal side AC and BC of 6 cm each. So we have to draw an isosceles triangle having 2 equal side as 6 cm and unequal as 4 cm. So we'll draw the unequal side over here, and we know that there will be one point which will be at the same distance of 6 cm from A and B. So we'll take 6 cm length on the compass and we'll draw 2 arcs, and the meeting point will be the point C, from which both A and B will be at same distance of 6 cm. So that's how we can use the application of point at the same distance from 2 given point. So students, this is all from this chapter. I hope this chapter is clear to you. I will meet you in the next video. Till then, keep learning, keep practicing, and keep constructing.